Now we will continue our chapters about parallelograms. Now we talked about parallelograms and rectangles. Parallelograms, if I want to prove that the quadrilateral is a parallelogram, first of all, we should prove both opposite sides are parallel, both opposite sides are equal, two opposite sides are parallel and equal, both opposite angles are equal, and the diagonals are have the same midpoint, or the diagonals bisect each other at the same midpoint. Next, we explained about rectangle. We said if we have a rectangle, we should find three right angles to prove that the quadrilateral is a rectangle. Next, we should prove that the diagonals are equal and bisect each other at the same midpoint. That means it is a rectangle. If I prove that the quadrilateral is a parallelogram and we find one right angle, just one right angle, that means the quadrilateral is a rectangle. And also, if I prove that the quadrilateral is a parallelogram by using the rules of the parallelogram, and we find that the diagonals are equal, then the quadrilateral becomes a rectangle. Now, in this video, or in this expression, in this lesson, we will talk about square and rhombus. Square and rhombus. First of all, we will talk about rhombus. Rhombus. Also, rhombus is a quadrilateral, has four sides, four angles, and four vertices. But it has something different than rectangle and different than parallelogram. First condition, if the quadrilateral has four equal sides, then so that we can say that the quadrilateral is a parallelogram, so that the is a rhombus. Here, if I prove that we have four equal sides, just four equal sides, so that the quadrilateral is a we can say that the quadrilateral is a rhombus. This is a rhombus. This is a rhombus. That means here this side equal to the next side, equal to the third side, equal to the fourth side. If I prove that all the sides are equal, that means the quadrilateral is can be rhombus. Now next rule, if I prove that if the diagonals are perpendicular, perpendicular and bisect each other at the same midpoint. So we can say that the quadrilateral is a parallelogram. Is a rhombus. If the diagonals first of all, if the diagonals are perpendicular, if I prove that the diagonals are perpendicular, and then we prove that the diagonals have same midpoint, that means the quadrilateral, we can say that the quadrilateral is a rhombus. This is a parallelogram, this is a rhombus. Here first diagonal, and the other one second diagonal. We notice that the diagonals here are perpendicular, and this one equal to the other one, the other part of the first diagonal. Second diagonal, we have this part equal to the other part. So we can say that the quadrilateral is a parallelogram. We can say that the quadrilateral is a rhombus, not a parallelogram, is a rhombus. But furthermore, now if I prove that the quadrilateral third point, if the quadrilateral is a parm, and the two consecutive two consecutive sides are equal. The two consecutive sides are equal, then the quadrilateral is a rhombus. This is a rhombus, or first of all, parallelogram. If I prove that this quadrilateral is a parallelogram and two consecutive sides are equal, this, for example, this side and this sides are equal, that means the quadrilateral is a rhombus. Consecutive sides, that means adjacent side, the two sides having same vertex, two sides having same point, having or intersect at the same point. Okay, if I next, or the fourth rule, quadrilateral. If I prove that the quadrilateral is a parallelogram, then if I add, for example, plus, we find that the diagonals are perpendicular then we can say that the quadrilateral is a rhombus. Here we can say the quadrilateral is rhombus. The rules of if you prove that the quadrilateral is a parallelogram, it's not one rule to parallelogram. We have 5 rules to prove a parallelogram. As we said before, if we have both opposite sides are parallel, both opposite sides are equal, two opposite sides are equal and parallel, diagonals bisect each other, both opposite angles are equal. If you prove that one of these rule, if you use one of these rule, that means if you find one of these rule, that means the quadrilateral is a parallelogram. If you find if you find that the two consecutive sides are equal, so the quadrilateral is a rhombus. Or if you add on the parallelogram that the diagonals are perpendicular, then we say it is rhombus. The last one is square. Last one is square. Square here has many characteristics. With respect to the square, is the father of the quadrilaterals, because a square is a parallelogram, square is a rectangle, square is a rhombus. But we cannot say that the parallelogram is a square, and we cannot say that the rectangle is a square, and we cannot say that the rhombus is a square. But we can say that the square is rectangle, is rhombus, is parallelogram. And furthermore, rhombus and rectangle we can say that the rectangle and rhombus, we can say about them parallelograms. But parallelogram isn't a square and isn't a rectangle, and it is not a rhombus. Okay, be careful about that. Let us talk about a square. First of all, with respect to square, if we have all sides are equal, all sides are equal, and one right angle, so the quadrilateral is a square. Okay, here with respect to this part, if you notice that this part all sides are equal, this is for rhombus. This is for what? Rhombus. We can say about it rhombus here. If I prove that this case is for rhombus, This is for rhombus. And then if I say that the quadrant has one right angle, it becomes a square. Here, all sides are equal. This rule, just if I prove that all sides are equal only, that means it is not a square, it is a rhombus. And then we add one right angle, it becomes a square. It becomes a square. Okay? Like this is a square. These sides, this is the first side, second side, third side, fourth sides. All of them are equal. And furthermore, we have this angle. If I prove this angle is right angle, that means the quadrilateral is a square. Okay? Otherwise, it will be what? Rhombus. It will be rhombus. Next rule, second rule, if I prove if if we have or if we find three right angles, if we find the three right angles and two consecutive equal sides, so we can say that the quadrilateral is a square. If I find three right angles in the quadrilateral and then two consecutive sides are equal, then we can say that the quadrilateral is a parallelogram. Then we can say that the quadrilateral is a parallelogram. Is a square, excuse me, is a square. So if I prove that this angle right and the other one, second one right, and the third one is right, just the three right angles, just only, not, it's not necessary to prove that four angles are right, just the three angles are right, and two consecutive sides should be equal to say that the quadrilateral is a rectangle, is a square. Here, three right angles, only if I find just three right angles, we cannot say that the quadrilateral is a square. We cannot say. If you said we have three right angles, it will be what? It will be rectangle. It will be here what? Rectangle. Here, this case is rectangle, not a square. Okay, this one is if I prove that the three right, if we have or if we find three right angles, we cannot say that the quadrilateral is square. We say that the quadrilateral is rectangle. And then if we find also more than three right angles, if we find two consecutive sides equal, or two consecutive equal sides, or two adjacent sides equal, then we can say that the quadrilateral is a square. Now third rule, if we have if we find if we find that the diagonals are perpendicular and bisect each other and equal, then we can say we can say the quadrilateral is a square. Here I can say this is the first one, this is second, three. If we find that the diagonals are perpendicular, bisect each other and equal, then we can say quadrilateral is a square. This is the here we have 90-degree, and this part equal to this, bisect each other and equal at the same time. Now be careful. If I prove, or if we find number 2 only, it is a parm. If I find that the number 2 only, this one number 2, if I find this number, that means the diagonals bisect each other, the diagonals bisect each other, we can say it is a parm, not a square, not a square. If I now, if we find number 1 and 2 together it is a rhombus. It is a rhombus, not a square. If I find that the diagonals are perpendicular and bisect each other, that means the quadrilateral is a rhombus. If we find number 2 and 3 together, it is a rectangle. It is a rectangle. If I find number 2, that means the diagonals bisect each other and equal, then we say the quadrilateral is a rectangle. So we notice that the square collect all of them. To collect, that means collect what? Diagonals perpendicular. Diagonals bisect each other. Diagonals are equal at all of them. These rules at the same time. Then we can say. That the quadrilateral is a square. Here, with respect to this one, we have what? We have another things about them. Here we have the meeting point of the diagonals in a parm or parallelogram is called center of symmetry. Center of symmetry. It is a point of symmetry. Okay, this one. This axis of symmetry this point, the meeting point, this or the point, the intersection point between the diagonals, called axis of symmetric, called axis of symmetry, center of symmetry. With respect to the rectangle, the rectangle has two axes of symmetry. Rectangle has two axes of symmetry, which are perpendicular bisector to the opposite sides. Here we have a rectangle. We draw a rectangle now, and we want to find the axis of symmetry. We take the middle point here. This is the axis of symmetry. This is the first one, which is perpendicular to the opposite sides, and the other one is perpendicular bisector to the opposite sides. These axes of symmetry should be what? Perpendicular. They are perpendicular to each other. These axes of symmetry. With respect to the next one, with respect to the square, or rhombus, with respect to the rhombus, not a square, we have two axes of symmetry, which are the diagonals. Which are what? The diagonals, because the diagonals bisect the angles. In the rhombus, bisect what? The angles. Here we have two axes of symmetry, and they are diagonals. So diagonals bisect the opposite angles in a rhombus. The opposite angle, that means this angle here equal to this one, the second one. Here we have this angle equal to this angle, and also this angle equal to this one. For the second diagonal, also this angle equal to this, and like that. Okay, so we said the diagonals in a rhombus are axes of symmetry. symmetry. With respect to the square, the third one, the fourth one, with respect to the square, we have so we can say about rhombus that has two axes of symmetry, and rectangle also has two axes of symmetry. But with respect to the square have square has four axes of symmetry. Has two axes of symmetry. First one, with respect to the axis of symmetry, the two diagonals, and the lines that are perpendicular bisectors to the sides. Perpendicular bisectors to the sides. So we can say that the parallelogram has center of symmetry, which is the meeting point of the diagonals. With respect to the rectangle, has two axes of symmetry, which are the lines perpendicular bisectors to the sides. With respect to rhombus, has two also axes of symmetry, which are the diagonals. But with respect to the square, has four axes of symmetry. Uh, one of them Two of them are diagonals. These are the axes of symmetry, and the other one are the lines that perpendicular bisectors to the sides. These are the axes of symmetry. Don't forget that the sum of the angles, the sum of the angles in quadrilateral is 100 is 360 degree. 360 degree. 360 degree. Thank you for listening. Waiting me for another videos about explaining maths for grade 7, grade 9, and grade 8.